Unit 6.4, prove triangles similar by AA. AA stands for angle-angle similarity postulate, and it states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And to take it one step further, if you think about it, if two angles of one triangle are congruent to their corresponding angles, there's only the third angle left. So in other words, in fact, all three angles are congruent to the three angles of the second triangle. So in the example here, you can see that, let's see, let me do a different color here. You can see that K and Y are congruent, and J and X angle are congruent. And then the last angle, by definition, not by definition, but by triangle sum theorem, that the blue angle L and the blue angle Z have to be congruent, and therefore these two triangles are similar, meaning they have the same angles, but the length of their sides are different, they're proportional. Okay, so it's a very simple postulate, but it's very useful. Let's see what we can do with it. Here's an example. Determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So what's given is, again, let's see, B and E are congruent. They're both right angles, right? So let's write that out first. So angle B and angle E are congruent because they're both right angles. And we also notice that here we've got 68 degrees at angle C, and at angle D we have 22 degrees, and these two are not congruent. However, you know that by triangle sum theorem, if I know that in the triangle ABC, for example, if I do 68 degrees, which is angle C, plus 90 degrees, which is angle B, plus the measurement of angle A, I should add up to 180 degrees. And because of that, the measurement for angle A is 22 degrees, and that happens to be congruent to angle D in the other triangle. So now, therefore, the conclusion we're drawing is angle A and angle D are congruent. Now, look, I have the first set of angles that are congruent. I have the second set that's congruent. Now I can draw the conclusion that angle ABC is similar to angle DEF. That's by AA similarity postulate. Okay, that's how we use this postulate. It's very handy, it's very useful, but remember, what does it prove? It proves that the two triangles are similar. Here's another example. Show that the two triangles are similar. And the first one is a small triangle, RTV, embedded in a larger triangle, RQS. Look, what's interesting is that this one, angle R, they both triangles share angle R. So if it's helpful, you can draw on the side. I'm not very good. RTV. That's one triangle. And then the bigger triangle, actually that's not too bad. RQS. You can separate them out, and that way it's a little easier to see. But it's not necessary. Once you get so fluent with it, you will be able to instantly see when a smaller triangle is embedded in a bigger triangle. So first thing first, I like to, unlike the guided notes provided to you, because they both have, they both share angle R, and angle R is congruent to each other by reflexive property. So I like to write that out first. So I've got one set of angles that's congruent already. And then next one, if you look at your diagram, you've got two angles at 49 degrees. So the first one, the smaller one, is angle measure RTV, and the other one is angle measure RQS, or simply Q, angle Q. These two are congruent. So of the big and the small triangle, I've got two sets of angles that are congruent to each other. So my conclusion, the statement I can write is triangle RTV is similar to triangle RQS by the AA similarity postulate. Okay, that's how we prove that one. Now, next one is a little bit more challenging. It's asking us to show that angle LMN on the left and the triangle ONP on the right, these two are similar. And let's see what's given. We have one set of congruent angles, so let's write that out. Angle L and angle, be very careful. This one is, you cannot do angle N. Rather, you have to be very specific about O, N, P, about the letters, because at point N, you've got three angles. If you only talk about angle N, we don't know which one you're referring to that's congruent to angle L. Okay? So that's all there is about angles. There's not much else given about angles at all. However, what's interesting is, notice these two arrows. So that's telling us, the arrows tells us that the line M and N, MN is parallel to OP. When we have parallel lines and a transversal, and like LP, for example, it cuts through the lines and it creates different interesting congruent angles or supplemental angles if we can find same side interior angles, right? So that was information we learned in chapter 3. So let's see what we can do about this. If we look at LP as the transversal, what's interesting is that we know that these two angles in red that I marked are congruent. So angle P is congruent to angle M and L, or LMM. These two are congruent by the corresponding angle postulate. Remember corresponding angles postulate, right? That states that when I have a set of parallel lines and a transversal cuts through these two lines, the corresponding angles are congruent. That was the corresponding angles postulate. And now I have the first set of angles being congruent, and then the second set of angles being congruent. So I can draw my conclusion that the two triangles LMN is similar to triangle NOP by the AA similarity postulate. So that's how we use angle-angle similarity postulate to prove triangles are similar. It's very handy. It's very rare that you'll be tested by to find similarities alone. You will find some of that in your unit quizzes, but for chapter tests, generally these are used in the context of proportions. For the purpose of this video, I skipped the next example. However, that is in your packet. The challenge for this unit is to read through that example by yourself. That incorporated portions, the concept of proportions. So make sure that you read through that. If you have any questions, come and see me. Thank you, guys.